Okay, just a quick review of today's class. So your homework for today was to complete the implementation of PlayingCardDeck. Here's PlayingCardDeck. Note I have two enumerations and I have these two static constant maps. So we'll look at the implementation first. That would be PlayingCard.cpp. Oh, the only thing really, there's a constructor to implement and get contents to implement. Now, I added color to my constructor. I'd like you to ignore that. I'm going to factor that out. I don't believe color should be there. Color should be derived from the suit. It shouldn't be for playing cards. For other cards, you might want to have color as an attribute that's part of the construction of the card. But for playing cards, really, color should be derived from the suit. Okay, so let's look at the implementation. That's PlayingCard.cpp. First, we have to load up these two maps. That's exactly like we did in the Monopoly project last year. We have a constructor. Here we go. And all the constructor does is take the arguments and, using an initializer list, initialize the members to the passed-in arguments. Here, because color was a method, well, we're not going to do color, but because color was something I stored on the card in my implementation, I'm running the base class constructor and passing it. I have a one-art constructor that takes color. And then get contents merely constructs a Q string with the rank and suit pulled out of those maps based on the rank and suit of the card. Okay, so the next thing we did is we reviewed our deck implementation, and we simply declare a virtual, actually this doesn't need to be virtual, we have a draw random card in deck, and we declare a vector of card pointers. And remember, in card, I did a type def of card pointer to be defined as a shared pointer to a card object. So this cards is a vector of smart pointers, shared pointers to card objects. And our constructor's job is going to be to fill it up. Now, deck is an abstract class. We can't construct decks. We construct derived classes like PlayingCardDeck. So next thing let's look at, here's our PlayingCardDeck, which really all it has is a constructor. So we build we just fill up a deck with playing cards. And we'll look at the implementation. It's simply nested for loops. This looks very similar to what we did last year for a regular deck of cards. Only last year our for loops, I believe, were running integers from 0 to 3 and 0 to 51. Here, because we have already these maps that we can iterate over that have the enumerations in them, the suits and the ranks, I iterate over the suits, and then for each suit I iterate over the ranks. And so for each suit I create one card of each rank in that suit, and I push it onto my card vector. Remember, we've inherited that from the parent, the deck. So after constructing a playing card deck, you have a card vector full of pointers to playing cards. And that was to be done in class, and then the homework was to modify your main controller so that currently the main controller just flips the card over back and forth between the King of Clubs, which is this string here, and just along with the card front image, which is just the plain white image for the card front. Now again, I've got this color thing in here, and I want you to ignore that for now. That should be done a little bit differently. That should be refactored. So this is setting the card front image, and then setting the text to be the contents of the card string. So what you're going to do is, for homework, add a member to the main controller, private member that will hold a deck of cards. You're going to instantiate a deck of playing cards and store the pointer, the deck of playing cards pointer, in your deck. So the controller doesn't really care what kind of deck it is, except when you instantiate it, you instantiate a deck of playing cards. And then here, rather than flipping over the King of Clubs every time, each time you flip, you're going to draw a new card from the deck of playing cards until the cards are all exhausted. And remember, our draw a card when that array is empty. Let's go back to the implementation of deck. Draw a card. If the array is empty, we return a null pointer. So in your main controller.cpp, when you're drawing cards every time the person flips over the face card again, remember to check for the null pointer, and if it is a null pointer, just don't flip the card over, leave them on the back of the card. Okay, so that was a quick review of what we did in class today and today's homework.